Now, there's something that I would like to add to the previous video, which is basically it's connected to the impulse thing. So let's say that I have an object which is falling from a certain height. So maybe this object can be an egg. Let's say this egg or any object which is falling, whenever it reaches the ground, so at the moment it reaches the ground, its velocity is going to be maximum. Now, once it hits the ground, then its momentum is going to change in such a way that it's going to change from a high value, which is equal to the mass times the velocity just before the impact, so before it hits the ground or at the moment it's hitting the ground, into zero. So this velocity is changing from a value to a zero, which is affecting the momentum. Okay, so the change in momentum is going to be simply equal to mv is if I'm talking about the magnitude. So here I'm not considering any direction here. I'm talking about the magnitude of the change of the momentum. So this is the value of the change in a momentum when this object is going to hit the ground. But if, for example, you were asked, is it better for this egg to hit the floor directly, or if putting a pillow would be better? So which scenario is going to be better in this case? Of course, logically, putting a pillow is better. But why is this? The reason is in this equation, which is the equation of the impulse, the I equal F net, and this is the average net force, times the time interval, which is equal to the change in momentum. So basically, for the same change in momentum, like here, I can't change the value of the change of momentum because this is constant. Because if you are going to do any accident, for example, then there will be a change in momentum that you cannot control. But what you can control is the time at which the change is occurring. So if I'm adding a pillow, then this means that this change in momentum is occurring in a greater time. Okay, which means that F net in this case, which is equal to the change in momentum, which is constant, over a higher time, is going to have less effect. So increasing the time will decrease the effect of the net force. If you want to understand it better, we can understand this using the force versus the time graph, and I believe this will be easier for you to understand, which I mean that, for example, if you have the force versus the time graph, which looks something like this, let's say this is the force versus the time. If the force looks something like this, okay, let me do it better. So if the change in momentum, for example, which is the area under the graph, looks like this, if the egg is hitting the ground, then by increasing the time at which this change is occurring, of course, the change is going to be the same. So the area under the graph is going to be the same, which will affect the peak of the force. So the area will look something like this, for example. Okay, so for the same area, imagine that this is the area under the red one is the same as the area under the black one. So if I'm considering the same change in momentum, if I increase the time, then of course the value of the force is going to decrease because the area is going to be spread over more time, which means that the peak is going to decrease. So I hope you understand this because this is a very repetitive question for the IB. They ask for the reason of why the egg, for example, should bounce on a pillow, not on the ground. So all what you have to do is to say this explanation. I hope this is clear. See you in another video.